Hello, geometry students. Welcome to Geometry Review Unit 2 packet. I'm going to talk my way through all these answers and hopefully explain them as I go well enough for you to understand on video. This is part 1. It may take more than one part to get through the whole packet, but here we go. All right, so looking at this picture here, angle EAB does not have to be a right angle. Am I supposed to be able to assume that? True or false? Oh, yeah, these are true false. I didn't have the instructions up there. EAB looks like a right angle. I could measure it with my protractor. It might be a right angle, but from the picture, there's no reason why that has to be. And notice it says not here. So it's true that it does not have to be a right angle. Can't assume that from the picture. 3 and 1 are vertical angles. That's false. 3 is a vertical angle with 2. Or I could say, I guess 1 is a vertical angle with 4. Those are two sets of vertical angles, but not 3 and 1. 3 and 1 are not across the intersection from each other. GAF must be a straight angle. That is true. One of the things you can assume from a picture is that if something looks like it's collinear, then yeah, it really is. So that's that. 4, true or false? Tomorrow's Friday is the hypothesis of this thing. I think the easiest way to figure that out is think of this as an if-then statement. In the book, they always did 1 underline for the hypothesis and 2 underlines for the conclusion. If it's written as if something, then something else. We just got to figure out if we're going to rewrite this as an if-then, what order would it really come in? Does this mean if tomorrow's Friday, then today is Thursday, or does this mean if today is Thursday, then tomorrow's Friday? What is this really saying? It's hard to sort this one out because they're both true, the original statement and the converse, but what is this equivalent to? I think, if you think about this as, the implies arrow is, that's what we call that thing when we do notation, and we do stuff like P implies Q. It's like saying if P, then Q. I don't know if that helps. But the equivalent to this is actually, yes, if tomorrow is Friday, then today is Thursday. So tomorrow is Friday is the hypothesis, and today is Thursday is the conclusion. And that makes this true. Okay. Statement and its inverse are 2 different names for the same thing. That's not true. This would be true if we had said contrapositive instead. Remember when you're thinking of manipulating these statements. It's hard to talk and spell at the same time. You're manipulating these statements, and you make the converse, the inverse, and the contrapositive. Okay, so original, converse, inverse, and contrapositive. I can't really abbreviate these really shortly because so many of them start with CO. These 2 mean the same thing, and these 2 mean the same thing. So the original and the inverse, no, they don't mean the same thing necessarily. In fact, no, they don't. They can both be true, but they don't mean the same thing. Original and contrapositive mean the same thing. Complementary angles always share a common side. That's false. You could have complementary angles. They could share a common side, but they don't have to. I could have a 30-degree angle here. It's a little big for 30. And I could have a 60-degree angle over here. And those things are complementary, but they're not sharing a common side. So that is a counterexample to this statement. Okay, 7. If I'm adding 3 angles and get 180, then those 3 are complementary. That's false for a bunch of reasons. First of all, you can't have 3 angles and call them complementary. But probably the bigger problem is the fact that we're talking about 180 and complementary. That doesn't go together. Oh, I gotta go answer my phone. Just a second. Okay, I'm back. I'm glad this thing has a pause button. Yeah, 180 and complementary don't go together, but even if this is supplementary, we would have had a problem with the 3 angles. Or if this had said 90, same thing. If we had 2 angles and 90, we'd be fine. Okay. 8, a pair of supplementary angles can both be acute. That's false. The reason for that, though, is kind of a pain. Basically, if I'm talking about, an angle that's less than 90 plus another angle that's less than 90, there's no way it's going to be big enough. If that, think about this. If that's less than 90, and this isn't a very scientific way to write this, but I think you get my point here. Like I can make a point this way anyway, that something less than 90 plus something less than 90 is going to be less than 90 plus 90, which is going to be less than 180. So there's no way to have them both be acute and still add up to 180. Number 9, vertical angles have congruent supplements. Well, let's think about that. Vertical angles would be like this. They have to be congruent. The supplement to this one is going to have to be equal to the supplement of this one. Whatever this measure is, say it's 17 degrees, so is that one. What's supplement to 17 degrees and what's supplementary to 17 degrees? They would both be the same, of 160. 3. Bad math students earn less money can be written as a conditional statement as, if you are a bad math student, then you will earn less money. That to me means the same thing. Yeah, read that over and over again. I don't think you're going to see it any differently. I guess the only way this could possibly be confused is because there's no if and then in this first statement. You kind of have to read this a couple times and go, well, if I think about this as the other way around, if I switch the if and the then things around, does that mean the same thing? If you earn less money, then you're a bad math student. That really is the converse of this. That means something different. That's almost like the less money is causing or somehow predicting the bad math studentness. But this one is saying bad math students earn less money. It's a statement about bad math students. So I think that kind of cements the fact that the bad math is in the if section of this statement. I wouldn't lose too much sleep over these. I think I'd just read them kind of like you'd say them and think about how people sort of talk and which sort of thing came first, and that's the part that goes with if. All right, always, sometimes, never. Vertical angles are, well, there's some. Vertical angles are always congruent. That's a theorem. Perpendicular lines, sometimes 45-degree angles. I'm sorry, I was thinking complementary. Never form 45-degree angles because they have to form 90. A theorem, I'm going to say a theorem is always a true statement because theorem is something, of course, has to be proved. And then that's what makes it different than a postulate. Postulates don't have to be proven, but theorems, you can sort of question them at the beginning, but we wouldn't call it a theorem unless it was actually true. So we're going to say always on that one. Postulate can be in proofs, but it doesn't have to be. Not every proof has a postulate in it. So when you're thinking about your proofs and what kind of reasons can go over here on the side of your proof, that's a T-bar proof, really small. Things that can go in this side would be things like theorems and postulates and definitions and properties from algebra and stuff. Anyway, postulates go in this list, but you don't have to have a postulate. Statement in a proof always has a reason. Yeah, so on the other side of this, every time you have a statement, you have to have a reason that goes with it. There's not, these are sort of one for one. So they all get their own reasons. Otherwise, they're unjustified. Even the first one that says given. Given is a reason. Choose the inverse of this. Oh, can I move this so you can see it better? Move that down a bit. Okay. Choose the inverse of the following statement. A rainbow shining implies that it has rained recently. Inverse would mean not, if not P, then not Q. So I changed both parts, the if part and the then part, to not. So this, first of all, it changes to an if-then statement and make it a little easier to dissect here. A rainbow shining implies, remember we thought it implies means we're going in the same direction as if and then. A rainbow shining, so it's like if rainbow. That's a B, boo. This thing's hard to write with sometimes. Then recent rain. Okay. If rainbow, then recent rain. Sorry about that. B. So the inverse is going to be, well, we did change this to not rainbow and then not raining. So if there's no rainbow, then it hasn't rained recently, which is, that looks pretty close, but that's a contrapositive. If a rainbow is not shining, there we go. There it is. It's at C. A, I think, is the regular statement. B is the converse. C is what I'm looking for, the inverse. And D, it looks like the contrapositive. Let me label the. Bam. Okay, there it is. Be careful when you read these through multiple choice questions. This whole thing started out with some true-false. There's not going to be true-false on the test, but I think that was a good exercise to go through to get you thinking about those things. There is going to be multiple choice, and this kind of thing here, like this little word inverse here, makes all the difference. That's what we're looking for in this statement. So people who read this little stem of the question too fast are going to look at that and go, oh, yeah, that means the same as this, and they're going to say A. Or, they're going to be thinking, what's the equivalent? They're going to say D. But no, I'm looking for inverse, and that's C. Be careful. Okay. Choose a statement logically equivalent to. Okay, remember what that means. Logically equivalent to, that's the thing that's going to get people on this. That means we're talking like original and contrapositive are logically equivalent, and converse and inverse are logically equivalent. I highlighted that a couple pages ago. If a number is divisible by 8, then it's divisible by 2. So when I'm thinking, I'm not even looking at these yet, but thinking logically equivalent, I'm thinking, okay, let's look for the contrapositive. There's other ways to say this statement and be logically equivalent, but you know what this chapter is about. It's about testing that fact about contrapositive creating logically equivalent statements. So let's just seek out the contrapositive and see if it's down here. Contrapositive would be if not this part, if not the then part, then not the if part. If a number is not divisible by 2, then it's not divisible by 8, and I just said word for word what's in D. I didn't even have to look at the other ones. Yeah, some of these might be probably the converse would be in here. If a number is divisible by 2, yeah, that would be C. That's the converse. B is the inverse. And A is just crazy with this might still thing. Remember, these knots kind of always have to come together, come in pairs. See, there's a not, and a not. Well, this one's the contrapositive. This one was the inverse. There were some wrong answers I saw in the last quiz where people would put a not in one half and not the other. It'd be like if a number is not divisible 2, then it is, or like this might still. That's what reminded me of it. People are doing that on the quiz, and it kind of puzzled me. The knots always come in pairs. Either they're going to be both not, or they're going to be both sort of not, or both be positive. Okay, if two angles are supplementary, then what has to happen? Well, that's true. That's sort of the definition. I see there's all of the above down there, so let's keep track of this here. That's true, but it could be D. One angle is always obtuse, the other is always acute. That sounds tempting, but what about the 90-degree situation? So that's kind of a problem. If they're both 90, then this is not really true. They share a common side. Well, clearly they don't have to do that because we've talked before about how one angle could be like this and one angle could be like this, and they could still add up to 180. So it's not D. That kills off D. It is just A. All right, this software is going to stop me at 15 minutes. I'll try to pause at a logical place before that. All right, given that, move this down just a little more again for you. Yeah, if HK, oh yeah, this one they call a bisector of the other segment, but on this segment they actually say, no, that's a midpoint. So we actually know that it's now the midpoint of both sides, but it comes in two different sort of flavors. One here, I'm saying HK is a bisector of JL, which makes X, I mean, it sort of makes X a midpoint, but that's not, again, that's not how they say it. The other one, they say X is actually the midpoint of HK. So if X is the midpoint of HK, the definition of midpoint is about splitting HK exactly into two equal pieces, which is what this part is here. So let's get this out of the way. This is definition of midpoint. The other one is that first statement here. Let me finish writing midpoint. This thing doesn't always track me as fast as I'd like it to. Looks like mid-paint now. The other part about HK bisects JL is going to put X halfway in here, or exactly in between these, meaning it's the midpoint then of JL. This fact came from the fact that it was a bisector. We don't know that it's if they had told us that a JX equals XL, then I could have said definition of midpoint tells me that, because that's the same sort of thing as these two things going together. But this one, I'm kind of trying to justify why bisector tells me that it's a midpoint, and that's actually the definition of how it was labeled up here. It's because it was a bisector. Because they told me it was a bisector, I know this is true. So that one's definition of bisector. Whenever you hear yourself say because it's a, like in A, how come HX is equal to XK? Because it's a midpoint, definition of midpoint. How come X is the midpoint of JL? Because they told me, because it's a bisector. So definition of bisector. All right, I think I've said in class enough that when you see these halves, you know that's theorem as opposed to midpoint. There was a question on the quiz, what's the difference between the theorem and the midpoint? Sorry, theorem and the definition. The definition is about the two parts being the same. The theorem introduces this half fraction, about the half of the total. Then how come I know JL equals JX plus XL? This would be true even if X were in a midpoint, so I don't care about X being a midpoint here. It's really just the fact that X is between J and L makes this true. This is actually a special case, special because it's midpoint, of segment addition. It tells you how you can add segments and get bigger segments because of the way the points are arranged. That's all that is. All right, I'm going to have to stop here, and we'll start part 2 in the next video.